Slope of a tangent strikes again. I'm going to do this once, putting it with a bit of a diagram to orient us, and then I'm going to do it again using just the formula that we're given, the f of x plus h minus f of x thing, and show that they give the same result. It's very good if you can set these up with a diagram using what you already know about slopes, but I understand that the formula is more efficient and you may just want to jump straight into that, so we'll confirm that both ways work. So we have x squared minus x plus 12, which is a parabola of some description, and let's see, this would factor as x minus 4x plus 3, which means it's got an x-intercept at 4 and another one at negative 3. That's 4, that's negative 3. Somewhere in between at 0.5 would be its vertex, so the x-axis is like here. Sorry, the y-axis is there, the x-axis is here. And they're asking about the slope at x equals 4, which by a bit of a coincidence is the point that I drew. That really was a coincidence, I didn't plan that. So here is our tangent line. And that line goes through the point where x equals 4, and the y value there is 4 squared minus 4 minus 12. That's 16 minus 4 is 12 minus 12 is 0. We knew that anyway, right? Because it's an x-intercept. So if you saw that coming, good for you. This curve goes through the point 4 comma 0. And now we're saying if we step just a little bit to the right and place another point on the curve, that point will be 4 plus h, 4 plus a horizontal differential, we call it, of h. And what's its y-coordinate? Well, we can get it by plugging into our formula. Let's clear out some of this clutter. If our x-coordinate is 4 plus h, that goes into our equation, and we get x squared minus x minus 12. And if we clean that up, 4 plus h squared is going to be 16 plus 4h plus another 4h is 8h plus h squared minus 4 minus h minus 12, which cleans up to h squared, 8 h's, then you lose 1, so 7 h's, and 16 minus 4 is 12, minus 12 is 0, so just h squared plus 7h is our y-coordinate. I'm going to put h squared plus 7h right there, and now I'm going to clear out all this because I need the space. Okay, so we start at 4, 0. We move to, say, 4.1, and then this would be 0.71, I guess, if we use those numbers. The point is, we move a little bit to the right, and we move a little bit up, and this tells us how much. And we can use our slope formula to get a slope out of that. The slope between 2 points is the rise, the difference in the y values, over the run, which is the difference of the x values. And here's how it comes out. y2 is h squared plus 7h, right there. y1 is 0. That's nice. x2 is 4 plus h. And the original x was just 4. So our slope is h squared plus 7h over, these 4's cancel, that happens a lot when you're doing these, just h. And so our slope is h plus 7. Now, that h is the distance between these 2 points, and we know that this slope estimate gets better the smaller h becomes. And so we get real greedy. Instead of just making h a small number, we say, what if h is infinitely small? Goes to 0. We can't take it to exactly 0 because then we get this limit is undefined and things blow up. But if we just get very close to it, which is what a limit enables us to do, we get h plus 7 here, which is 0 plus 7. The slope is 7. So that is our answer, building everything up from geometry. If you do this fast, it's not going to look all that different, really. But the formula says you do the limit as h goes to 0, f of x plus h, or sometimes you see a plus h, it doesn't really matter, minus f of x all over h. And let's see what we can do with that. Limit as h goes to 0. F of x plus h is exactly this. It means you plug x plus h, in this case 4 plus h, into your formula, and you get h squared plus 7h. From that you subtract f of x, which is simply 0. Subtracting 0 is a little bit pointless, but that's okay, we can do it. Limit as h goes to 0, h squared plus 7h over h equals h plus 7. And then as h goes to 0, the same thing happens. So you can set this up from what you know about slopes, or you can use the formula and get the same answer in a few fewer steps.